When you look up at the night sky, you see a quiet, static painting of peaceful, distant lights. In reality, you're staring into an active war zone. Out in the freezing dark, some stars refuse to burn out and fade away. They transform into relentless, active predators to feed their own starvation. The cosmos allows deceased celestial bodies to survive by hunting down and consuming their living neighbors. This predatory cycle begins in a binary star system, two massive stars locked together in a tight, inescapable gravitational dance. This diagram shows what happens when one star runs out of fuel. It collapses into a tiny stellar corpse called a white dwarf. Packing an entire sun's mass into an Earth-sized sphere, its extreme density creates an immense, disproportionate gravitational pull. That gravity turns this dead star into a permanent trap, forever starving for new matter. This wireframe model maps the Roche lobe, the indivisible, teardrop-shaped boundary of gravitational dominance around each star. If anything crosses that line, it belongs to the white dwarf. As the blue giant swells, its edge touches that boundary. The trap snaps shut. Stolen gas from the living star is ripped away, spiraling down into a violently hot, swirling accretion disk around the dead star. A massive blue giant, millions of miles across, finds its matter effortlessly siphoned away by a corpse thousands of times smaller than itself. This is a cosmic parasitic infection. The dead actively feed off the living, ensuring a fatal outcome for both stars. We are witnessing cannibalism on a planetary scale. The blue giant's gaseous skin is peeled away molecule by molecule in a violent plasma stream. The white dwarf has no off switch. Its pull is continuous. Its hunger is completely uncontrollable. As millions of tons of this stolen mass are aggressively packed onto the white dwarf's surface, internal thermal instability spikes. Looking at this cross-section diagram, we see the white dwarf's atomic structure vibrating under the pressure. It simply cannot hold infinite mass. By blindly consuming its neighbor, the parasite pushes itself toward a critical threshold, turning a slow theft into a ticking time bomb. That structural collapse happens at an exact mathematical threshold, known as the Chandrasekhar limit. Named after the astrophysicist in this portrait, the limit establishes that a white dwarf cannot exceed 1.4 times the mass of our Sun without collapsing. The millisecond this mass limit is breached, the immense pressure forces carbon and oxygen atoms in the dead star's core to fuse instantly. No matter how much matter is stolen, the laws of physics will inevitably step in and violently correct the imbalance. Core fusion triggers a runaway thermonuclear blast that ignites the moment the limit is crossed. Astronomers call this catastrophic event a Type 1a supernova. The detonation is absolute. It vaporizes both the parasite and the host, erasing them from the map of the universe. Yet this violent end forges and scatters new heavy elements, providing the raw materials for future planets. The universe is a violently recycled graveyard where nothing cheats death forever. Are you actually living, or just letting the clock run out? Follow for more impossible facts.